record on this computer. And so typically usually, the past couple of times we got into this week, we hadn't had an exam, and what I had scheduled was these two exercises, functions part 2 and sorry, not here. I had these separate exercises set aside, additional exercises on loops, and exercise on translating things into Pig Latin. I have other videos from other semesters where I've gone over those because I did those, but because I'll be reviewing today, we don't really have time to do those. But if you want additional practice, especially with regards to how to return functions, that is what to study. And they're very good practice for getting to, especially with regards to the next homework, which will be module 6. But I'm sure you don't really, you're not really focused on that now. You're focused on the exam on Thursday. So let's go ahead and get straight into it. We will, I will go over the practice exam, and hopefully we should be able to get all the way through it. Again, the actual exam itself is going to be, I feel, much more focused and easier, much less time consuming. I figure more practice is always better than less practice, right? So, so let's go ahead and get this open. Okay. So let's go ahead and start. True or false? Computer science is the study of computers. False, right? It's the study of algorithms. Okay. Alan Turing is often considered to be the first programmer. False. False. Ada Lovelace is often considered to be the first programmer, which again ducks down right beneath you to who is Ada Lovelace and why is she an important figure? Because she worked on Babbage's analytical engine, specifically making her the first programmer. These things, for the exam, all I have to say on that one is just review your first lab and you'll be fine. Okay, for questions of these natures. I have a lot less questions like this on the actual exam. Again, variety. Okay, so what do these evaluate to? 2 times 3 is 6. Divide by 6 becomes 100. Becomes 100, right? Yeah, 1 times 100. All right. This B over here, 1 mod 2 is 1. Whenever you mod by 2, that's asking whether or not it's an even or odd number, and you get 1 back if it's an odd number and 0 back if it's an even number, right? It's the remainder after you divide by 2. So this is just a convoluted way of me writing 1 plus 1, right? Which my son so enthusiastically tells me is 2. He loves math. He's really into math. All right. -1 plus negative 10.5 is prime you to remember that floats are a thing. So again, negative numbers are fine. So that should be -11.5. All right. This one is, again, D over here is to remind you about order of operations, right? All of these can be checked by plugging them into idle. Like so, I hope. Let's see. I mean, it depends on how we encoded them, but all of these can be checked by plugging them into idle. Except, of course, that you'll see that again. This came up in one of your book exercises where sometimes the characters that look like a character aren't actually the character in question. Similarly for that, right? So apparently this star and this, right? So again, order of operations here takes effect. You multiply first before we do anything else. It's the same order of operations you've been dealing with throughout all of your math education. Okay. So it would be 9 minus 6. Okay. Reminder that anything multiplied by 0 is 0. So all this is nonsense and you shouldn't bother trying to work it out. Again, this was designed for no calculators in mind. So 0 minus 1.0 turns this entire thing into negative 1.0. Again, order of operations, simply applying here, it's 8 minus 20 becoming negative 12. Yes. I would dock you a fraction of a point if you forgot to put 0.0, because you're differentiating between a float and not a float. Right? So full credit would be writing negative 1.0. If you forget the 0.0, I don't know whether or not you understood about it being a float. It's a completely different thing. Similarly to here, right? 7 divided by 3, right? Here, when we've got 2 slashes, that is integer division. Remember to keep an eye out for integer division versus, floating division. So 7 divided by 3, that 3 goes into 7 twice. So this becomes 2 plus, and then we've got more other operation over here, 6. So this also becomes 8. Assuming I can draw that with my mouse, which is not so easy apparently. Okay. Here we go. Okay. 4 mod 2 times 3. So modular arithmetic should take the same precedence as any other division operation. So this would just simply be 0 times 3. All right, and we plug that in, and again, we should be able to plug that in to C. Okay. This one is I'm always a fan of these kind of things where I throw a big number and another big number at you. Just to remind you, the way that this works in Python is that small number divided by a larger number, if you're doing interdivision, is 0. And remember here that pound or star is square it. Yes? Oh, okay. Yeah. So this would be 100. So this would be 10 squared, which is 100 times 2. And remember, exponentiation is before all the other stuff. So it's not 10 to the 4th. All right. So these next ones are deliberately designed to kind of make sure that you understand one of the fundamental principles of the way variables work in computer science, which is that you can modify them. So now in these cases, the key to your success is not doing them in your head as much as you want to, because that's a great way to mess up. So we've currently got x is equal to set. We've got currently x is 7, y is 8, and z is negative 5. All right, x is equal to x plus 1. That means we take whatever's in x, which is 7, add 1 to it, so we get 8, and then we store it in x. So x becomes updated to 8. Y is now x, whatever's in x, plus whatever's in y, plus whatever in z. So it's the sum of all these things together, which is 8 plus 8, which is 16, plus negative 5, which is the same as minus 5. 16 minus 5 is 11. All right. So this becomes 11. And then z is the plus equals 1. That is shorthand for increment by 1, which is one of those things where, again, I will knock you partial credit for this if you mess it up, because you see negative 5, so I'm going to increase that to negative 6. But that's actually the wrong direction, should be negative 4 instead, because you're adding 1 to it. So 8, 11, and 4. And please correct me if I'm doing these wrong, because I haven't checked these in like years. Yes. I'm sorry, negative 4. It's just testing you, obviously. Sorry, I'm saying that with a big grin on my face and that you can't necessarily see because of the mask. All right. So true or false, right? So first off, A, true or I don't care anymore. It's true. One side of an or, when one side of an or operator is evaluates the true, I don't have to bother looking at the rest of it, right? It's all true. They'll just put T here. It's fine if you put T or F. Perfectly fine. Not false. That means not just means we flip it. Not for, so not 4 is less than 2. Is 4 less than 2? That's a false. And the not means flip it to a true. And then and 3 is less than 10. So true and true becomes true. This one's a tricky one because this is so this one is not one so occasionally I throw things up over there where I want you to make your best stab at it. I don't do that on actual exams. On practice exams, totally fair game for me to do that. Because, you're like, okay, on the left, we get 4, and on the right, we get 4.0, right? Does Python consider those things the same? That is the question we have to ask ourselves. And it's perfectly reasonable for you not to know that because I can't remember off the top of my head. 4 is equal to 4.0. True. Python, in this case, Python cares about your intent here, right? And that makes sense. So, and now the reason that is because in order to compare them, okay, you got to convert that integer into a float. So the 4.4 gets translated into a 4.0. This is the way it works in other programming languages. Remember, anytime that an int interacts with a float, the int gets converted to a float. All right. And then I have this obnoxious thing over here. Okay. So again, if I give you something obnoxious, and I'm not going to give you something that's obnoxious on an actual exam, what you want to do is that you want to, again, scratch out stuff. So like, we've got parentheses here. It doesn't matter really the order I do it in, but again, I've got this whole true or, so this becomes true, right? And not, so false or true becomes true. So not becomes a false. So we've got true and false. An and operator needs both sides to be true. So this becomes false. And then we've got this outer one, which flips it to true. And for easy checking, all the answers were true. Never assume that just because I put something never assume that if like all the answers are the same or something that you're wrong. I mean, random chance, if the answers are truly tossed out of a hat, random chance dictates that out of 5 questions. If you have a series of 5 questions, in true or false that you experienced in your life, at least like 1 in 32 of them should be all the same answer in a row. And we don't like that because that doesn't look random. Yes. They're all true. It becomes a not surrounding a true and a not surrounding a true and false. So this is currently inside parentheses. So we evaluate that. And then we evaluate the not. Sorry, then we perform the not operator on that. You will never, I will not say you will never find anything that's logically complex in the real world. But if you do find somebody who wrote that, you should probably like yell at them or something. Because generally because at the very least, if you're doing something like that, you should break it up into if statements. Remember, readability means everything. Okay. So now to refresh your memory about slices, I think I threw like 1 question about slicing on the exam. So, and not nearly as annoying as all this. I don't even remember what this comes out to. So, but again, so A3, right? A at index 3. So when you're doing these kind of problems, best to write it to write it. 0, 1, 2, 3, 4, 5, and so on and so forth. The easiest that way to figure that out. Of course, for me, it's a bit hard with, you know, yes. They count. Yep. Yep, they count as part of the index because a space is a character. That the quotations tell us where it begins and where it ends. So, and I'm not going to try anything clever about escape characters right now. So 0, 1, 2, so this should be A because it gets, this is the third character over here. A 3 to 8. That means start here, 3, 4, 5, 6, 7, 8. So that is apple. Because we go up to, but don't include character 8, which is a space. If you want to be clear about it, just put, you know, put your quotations a mark around it. Okay. Now then I've got some real nonsense over here. Okay. So first off, negative indices. Anybody remember what those do from the videos? They start from the back. So B -2. So -1 is E, -2 is B. This is B. A3, we've already solved that. A, okay, I have a feeling what this might be. So BA, and then 1 to -1, so 1 to the end. So BA, and then, and so that should be ban apple a day, right? And then times 2 would give you, would be repeat that twice. So obviously this is not something that's conducive to writing on a single line. Why is A? Because yeah, it does start at index 0. So because you've got 0, 1, 2, 3. Okay, and now let's clear this. So this one is, you know, it's been apple a day, apple day, or something like that. Here, we will go ahead and copy that over. Or rather, we will go ahead and copy these just simply to, because I cannot fit that all. And that was a terrible question on my part as a result. So, boop, boop. An apple a day, B. And remember, there was something clever I did with this back a number of years ago, but something like number of hitting character with okay, and then we set up A and B respectively, and now we go ahead and I will grab this. Oh yeah. And that's just a way to write actually banana. Oh yes, okay, yes, I totally messed up on this part. Right. So I knew what it would be, but I'm like, why am I not getting it? All right, BA 1 to -1. In other words, 1 all the way to the end. Sorry, 1 to 0, 1 to 0 by -1s. In other words, from this over here, all the way down to the end by -1s. So, and not including the end, because we don't include the end point. Or sorry, NA, and then, wait, I guess we do. NA twice. So 1 to the begin, yes, 1 to the beginning. That's what this means when we keep it out. -1. Yes. Yes, because what we're doing with the colons is that this is saying 1, go in reverse, figure it out. And the middle is telling Python to figure it out, which means go to the end. And if we're going in reverse, then the end is the beginning in that case. And if we're going the other way, the normal way, it would be all the way to the end. I totally missed the first column when I was first explaining this. See, this is what happens when I don't look at this. And this one, okay. Ah, yes, this is where I did something clever. So this is every other character starting at, this one is every other character starting at 2. So starting at 1, which would be HID, oh, it's hidden message. Or something. Hidden, it's hidden something. Right? Every other character from it. We can just simply figure out by, we don't even have to evaluate it. We can just simply scratch it out. Hidden, remember the spaces count. So it's hidden message. Am I going to do something obnoxious during the exam? No. The practice exam is for me to do things that are obnoxious. Nope, the double colons mean to so the double colons basically are parts of the separator. If you have one, so basically it's always start colon to ending point colon by step. If I leave out any, if I leave the start blank, it assumes start at 0. If I leave the end blank, it means get until we get to a terminating point, either the beginning or the end. Okay. And if I leave the step blank, it gives me 1. Oh, sorry, it gives me go up by 1. So this simply changes so whenever you see this, it changes its parameters. So the easiest way to make a copy of something in Python is and this is relevant for the next one. The easiest way to make a copy of something in Python is to just simply say, okay, we've got, so let's go ahead and take banana for a second. B is equal to banana. If I wanted to make a copy of that, I would say B from the beginning to the end up by 1s, and that gives me a copy of it. Incidentally, if I wanted to do a copy from the end of it, sorry, if I want to do a copy in reverse, all I would have to do would say be B colon colon -1 from the beginning, wherever that is dictated to be based on this, to an endpoint in reverse. An ab. And an ab or something. Which brings us to this one, printing it out in reverse. Takes in a text and reprints the string in reverse. I don't specify whether you have to print it out in reverse all at once, or if you have to print it out all or one character at a time. I would assume all at once, but if you did it the other way, whatever. Okay, let's go ahead and see how many different ways. Now, this is the type of question I love to ask because when I ask for people to complete a function, and I don't think I'm trying to remember if I put one on or not. A lot of it was reading functions, not writing a function, following directions. This one, I like it though, because there's so many ways to do it. There's, of course, just simply print the text in reverse, like I just showed you, like that 1-line solution done. Okay, you did your homework. You really got into slices. We can test that by doing print, by calling print reverse. And again, we'll do banana because that is an easy word to spell. Well, actually, it's a hard word to spell because it's very hard to stop spelling it. Okay, so that one prints out banana like we'd expect. But another way to do this is that we can use the accumulator pattern. Okay, and there's different ways we can use the accumulator pattern. Like, so we could do reversed. Reverse is equal to, and you always, no matter how we do the accumulator, we're always going to start with an empty string. So one way to do it is that we well, go through this in reverse. For I in range, so we can go over the range, for instance, like this. Okay, we could go over the range like this and simply say, hey, from the end, from the last index, which would be length of the text minus 1 to the beginning of the text, up to and including the beginning. This one's annoying to do. Minus 1, like that. Like I said, there's a lot of different ways to do this one. Reverse plus equals text I, and then print reverse. And I'm moving quickly, it's because we got a lot of stuff to do. Okay, print, so it's an at F. Okay, again, reverse. Another way to do that is just simply go, is that we could go for letter in range, sorry, 4 letter in the text. Okay, and then what we could do is we could do, rather than reverse plus equals, we could do reverse is equal to letter plus reverse. So here we can reverse it by just adding each letter to the front of what we already have. One of those weird things you can do with accumulators with strings and with lists as well. You can add it to the front. So that also works. There's multiple ways to do this. As long as you got the correct output, I don't care how you did it. Okay. Okay. So this is one of the, so these are questions that are definitely what you should be focusing on for the exam, because I asked quite a few of them. So, which is write the draw the result of what we've got going on below here. Okay. So here I've got a pattern, a program called question Ziggy. I create a Bob, I define a function, and then I say Bob, pass it into the function, and pass a 5 into the function as well. So I pass in, whoops. I pass in Bob and 5. So for this, what we're doing is anytime we see length, we would do 5 instead, which effectively means we do this 5 times. Well, sorry, this technically, which is Bob. So here I'll go ahead and start Bob here. Bob, turn right 45 by 45 degrees, meaning he's going to face this way. Forward some amount, which is 10. That's really small, but whatever. And then then left 90 degrees and forward 10. Okay. So, and then let's see. So left forward 10, and then right 45 degrees. So he'd be facing, so what we did is that we went 45 degrees this way, 90 degrees this way, and another 45-degree turn. Okay. Which means that he's faced, so that's like negative, that's basically negative 90 plus 45 plus 45, right? It cancels out, meaning he's starting in the same position as before. So essentially we make 5 of these sawtooths. Something like that. Except, as drawn by a computer as opposed to somebody who has terrible hands. All right. So now suppose I change the program to the following code. What changes? What ability does a person calling question Ziggy 2 now have that they did not have for question Ziggy, for the original question Ziggy? Not how much they're going to turn. How much you go forward, which does what? It changes the size of the teeth, right? That's what I'm effectively looking there for there. If you're saying, oh, you can change the size, I mean, yes, technically, but or if you say that now there's a size variable instead of a 5. If you say there's now a size variable instead of 5, that doesn't tell me anything. If you tell me it changes the size, that actually tells me something. All right, draw the result of the program below, you can draw a dot to represent a stamp, right? Because yes. Yeah. Yeah, I just wanted you to explain, yeah, what makes it, now suppose I change it. I don't say to tell me what it looks like, right? Just tell me what, I mean, all I changed was adding this and replacing your fives, sorry, your tens with the size. All right, so draw the following. Let's see. So now this one says, draw the result of the turtle program below. You can draw a dot to represent a stamp. So this is one of those, again, I haven't taken a look at in forever. So we've created a turtle. And then we've got bob.pen up, which means that we aren't drawing any lines around the place. Okay. Generally, if I'm asking the question about stamps, I'm not going to be asking. I'm not going to be asking you to do something similar. Yes, you have a question. Okay. Well. All right. So 4 row in range 5. So we're going to do 5 of this nonsense. Okay. Okay. So, and generally, I don't name my variables nonsense, except for a question in the past, I have written for the past 2 semesters for the final exam, I've written a question where I deliberately give you a program with nonsense variables, because the point is for you to figure out what those nonsense variables are and explain what those parameters actually are. But generally, I'll name them things that are not, I will not name things that are like counterintuitive. Right? I'm not going to name it rows when it's actually columns. So 4 dot in range row +1. So this changes as row does. So row values are 0, 1, 2, 3, 4, which means that the range that this 4 dot in range, the value row, that's going to be row +1, meaning it's going to go 1, 2, 3, 4, 5. So in other words, this loop is going to run once the first time, twice the second time, 3 times the third time I get to it, 4 times during the 4th loop, and 5 times during the 5th loop, assuming you can actually write a 5 again. So what does this mean? Well, just taking a look at the code and not actually even performing anything, we see that the only stamp, which I mentioned over here, the only thing that we actually, where the turtle draws anything, does a stamp, is in this loop. So that means that we're going to put down 1 stamp during the first, during this first thing, the second stamp, and then we're going to do 2 stamps in a row, then 3 stamps in a row, then 4 stamps in a row. So without any of this, right, without any of that code, essentially, let's just do it without any of this code. So the first time we do this, it would be dot in range 1. So let's repeat once, dot bob stamp, then move forward. Then we do 2 stamps, 1, 2, then 3 stamps, 1, 2, 3, and then you'd move forward to the next to get ready for the next position. Then 4, 1, 2, 3, 4, and then he would do 5, right? Makes sense? If we didn't have any of that code there. So all this code, obviously on the bottom, what that's got to do is rearrange how this is going to be laid out. So what we're going to do here is that we are going to, so that gives us an idea of to just help check us. So first row, we do this, we do it once, then bob dot. So let me go ahead and just sketch over here. Bob is going to turn to the right 90 degrees. So instead of facing this way, he's going to go to facing this way. He's going to move down 50. So he's going to move 50 this way. Then he's going to turn right 90, which means that he's going to turn this way. And then he's going to move forward row 50 times row +1. In other words, he's going to move 50 times the amount that times the number of dots we did, right? And if we notice, this value forward 50 is equal to the total number of times we did over here. So in other words, this is just simply saying move back to where you were. Okay, this basically says, so these say move down. Okay, that's what these two things say. These say, Bob, go, you're here. You've done the dot, move down to over here now, and now move back as far as you moved forward. So you can be ready for the, next part, which would be over here. So then we do 2. Then it says, Bob, turn down, you're facing this way, turn to the right, which means face south. Move down to the next row, which would be over here. Then turn another 50 degrees. So turn another 90 degrees so that you're facing around, and move forward exactly as much as you moved forward before, right? Because he moves forward dot, and then he moves forward over here. Then it goes dot, dot, and then he's here. And he goes dot, 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 then he's here. He turns down, he moves back as much as he moved forward. And then he turns, and then this last thing, this right 180, turns him around so that he's facing then a full 360 degree turn. So the end result is that we get a pyramid that looks like this. 1, 2, 3, 4. And there you go. That's what the answer should be. Again, nice thing about these is that you should be able to check them. All right. Now this one is useful for the next program. Okay, which is that, so we're going to do this. Complete a function so that the turtle passed in as an argument draws a square. Now again, there's going to be less of code writing in this exam for you. A lot more of code following, less of this turtle doing things. There will be something, let's see, do I have it here? Do I have one in here? No. I do not have something of that effect right here, right now. But what I do plan on doing is giving you some code that is almost complete, okay? But it has some blanks in it, like fill in the blanks to complete the code, and filling in the code will give you this image. So like I'll have, here's the code with missing parts, here's what I want, fill in the blanks please to get what we need. Because if I give you something like this, it could really be eat up time consuming. And again, I'm trying to keep this quick to like a 50-minute exam so that we can do the 2-phase portion of it. Okay, so to draw a square, so write a function to draw a square. So to draw, we've done this a lot of times. So let's go ahead and we will keep this over here. And I'll just simply say import turtle. Okay, just so that we'll have it. And then I will write a def draw square, which takes in one variable. That's what it said. Take in one variable, sorry, 2 variables. Bob, the turtle that's actually going to perform the drawing. And then we're also going to take in how big a side is. Right? So 2 arguments. So, and we've done this before. We've seen this many times, which is 4. What we do is we basically say, just do this 4 times. 4 in range. And I always like to arrange it so the turtle ends where he starts, in the same direction that he started in. It makes it a lot. It makes it a lot less mentally taxing to call. You know, instead because if I do multiple draw squares, I would have to be like, okay, where did the turtle end up though? You know, so 4 Bob in range, right? I'm going to do this 4, and then Bob dot forward. He's going to move forward side amount, and then he's going to Bob dot right, turn right 90 degrees. Boom, boom. Okay, that's all we really need to do for that. I mean, I can do Bob is equal to, or I can say Alice, so our variable is equal to turtle dot turtle. Okay, and then what we're going to do here is that if I do draw square, I can pass in Alice, and I can say I want the sides to be 100 in size, and then I can run it. And then we see Alice drawing the square. Now, why I put Alice, but the name is Bob. And essentially what Alice does is when she gets passed into the function, she takes the name tag of Bob and sticks it on her. Okay, so just remember that these things are their own little worlds and that the arguments are positional. These are just name tags for actual names, which are incomprehensible to our non-machine minds, like 0x572558, you know. Those names don't make any sense to us, so we use variables instead. Oversimplification of it, but it gets the idea. Okay, now the next thing is we want to draw this. Okay, so on the exam, expect a draw this. You know, expect something where I have the output, and I want you to have and I want you to complete the code. Probably still have to write that question, I think, but we'll see. So draw square, right? So here we've got, you can create more functions if you need to. Here's your picture, and I give you a hint here that that the turtle drew 4 squares. He didn't draw one. He didn't do like, you know, how many squares do you see in this picture? It's not 4, you know. It's he drew 4 squares, and the way to do 4 squares, if you think about it, oh, the only way to get all the lines in here is to draw 4 things of about this size that overlap like this, right? So let's think about what the turtle needs to do. Well, the first step is if I draw a square, I'm gonna go, oh wait, I've got a pen. Why am I trying to do that with? So go here, 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 and here. And now the turtle is again facing this way. So then what I want to do is I want to get here, right? So that I can, and then I could do the same thing. And then I want to get to that midpoint, right? So simply put, I need to draw a square of side length, and then I need to move down and over an amount equal to side, right? Or sorry, side over 2, half the amount of the side, right? We can, and this is one of those that if you have a computer, you can kind of try it with trial and error, but what we're going to, so I'm going to just show, I'm going to leave in a mistake, and then we'll just see how to fix that. Okay. Def draw 4 square. We're going to take in Bob and how big the side is. And again, you could, I'm writing a function. I didn't specify you had to. So what we're going to do is we're going to tell Bob, hey, Bob, you need to draw a square. Or so draw a square. Bob, okay. And then a bunch of indentation is going to happen later, but because I want to get this first part done, because once I do this part where I draw this first square and then get over to this corner in the middle, then I just have to repeat that action 4 times. And it makes sense since that's where the turtle ended up in my square, in this output. So draw square, Bob, okay? So then Bob dot right 90 to turn him down. And then when we turn down, we're also going to have to turn back to face the original direction. So I'll go ahead and do that. I'll go ahead and do the inverse operation now. Bob dot left 90. So in between that, we want Bob to move down. Where do we want Bob to move down? Or how much do we want him to move down? Well, this entire length was side. We want him to move down side over 2. By 2. And I don't know if it's friendly with floats, so I'll just go ahead and do an integer division there. But on an exam, I really wouldn't. On a paper exam, I wouldn't care if you did divide or divide. It's just one of those things that I would just be like, that is not what I am testing you on this question. Okay. I have very specific criteria for each question. Okay. Bob dot right, Bob dot forward, and then we turned him to the left. And then we say Bob dot forward side over 2 to move him to the right. So now he's in the center. And so all I need to do actually is just do this step, do these things 4 times. We know how to do that. 4 in range 4. Just repeat this 4 times. And we've got an answer, although I left out a step, which you're going to see. So I did make a minor mistake. Oh, aside from that, besides leaving out the 2, which again, minor mistake there. Okay, doom. Oh, right, got to actually call it for it to work. So draw 4 square. We just simply drew 1 square. Missing positional argument side. Oh yes, draw square side. Do. So the only mistake I made, as you can see, is that I've got an extra line over here. Now that extra line comes from the fact that so the extra line comes from the fact that I drew a square and then I drew while I was moving, right? So what we want to do over here to fix that is Bob dot pen up. When we don't want to draw, we just surround stuff with a pen up and a pen down. Okay, so we got what we needed over there. Now, for the other question, very similar, just after I draw my first square, 1, 2, 3, 4, well, I turn down and move down, and well, it just changes up, but it is still 4 squares. I draw 1 over here. See, I draw 1 over here, and then I draw 1 over here. I think all that's fixed there is the rotation is that I have a sneaking suspicion that if I leave this out, sorry, if I leave forward dot right, if I leave this part out, nope, not that one, but still looks really cool. Let's see. So I'll come back to that one because I don't want to work because I want to make sure we get to the other ones right now. Because I don't want to work on something that's, again, we have here. When there's this one, which I think was especially important, I had somebody ask me about that a couple days ago. Maybe it was yesterday. I don't know. Time's been an infinite blur since the pandemic started back in, was it earlier this year? I don't know. Again, it has been just one long thing. All right. Worst Groundhog Day ever. All right. So this one has a function called foo. What it does is that it prints foo. Then we've got a function called bar, which calls foo, prints bar, and calls bars. Then we've got bars, which prints bars and calls foo. All right, so basically all this means is when you see something like this, abandon basically your creative thoughts and just follow it like a machine. First command, foo, prints out foo. Second command, bar. We're in bar, bar calls foo. Sorry, bar calls foo. We print out foo again. Then we do bar, and then we do bars. Bars prints bars and calls foo. We print out foo, And then finally, we do Boz again, which does Boz and prints out foo. Is that what other people got? Foo, foo, bar, Boz, foo, Boz, foo? Right? No? Did people get something else? Yeah, so actually these are the classic metasyntactic variables of other programming languages. Traditionally Python uses spam and eggs as their metasyntactic variables. In other words, variables that we use in place of as names for other things. That comes from the Monty Python skit Spam and Eggs, which very good skit. Other languages like French have their own set of metasyntactic variable. English, though, because of military background in this stuff, we see the foo and bar come from the jargon of foobar. Yes. Let's see. Well, let's see. I mean, I'm pretty sure I tested most of these when I wrote them. But, you know, there's always the possibility. All right. No, it's fine. We can declare, just like Python, just like Java, we can declare, we can use them before, as long as they get declared at some point. We can use commands so long as they get declared some point, as long as it's in a function. Okay, if they're in functions, that's fine. Apparently. But like, if I were to try, I don't think I could do this. I don't think I could do this. Oops. So to your point, I don't think you can do this, because when it reads it, it doesn't execute these things. It doesn't try to execute the definitions yet. It just simply marks down what it needs to do, essentially. Reads over it and says, aha, we're defining these operations. I'll actually do them later. But if I try to do, but now if I try to call them, right, I'll get the foo function isn't been defined. So as long as we're calling, so it's a weird subtlety, but because Boz hasn't been defined yet, but it's inside a function call, therefore it's not been run yet, it's okay for me to define it in that manner. So now comes the question of sorry, the next question, which is, if we change Boz to be Boz foo bar in this question, so if we just simply change this over here, it'd be that. What happens? Well, so once we get the bar, Boz will call, sorry, bar will call Boz, and Boz will call bar, which will cause, yes, exactly. It's an infinite loop. They'll call each other indefinitely. Generally, not a good idea to do that. All right. So these next two are worthwhile to know about. So the idea here is that I intentionally make these to be these ones to be confusing. And if you test that, you probably were like, I have no idea why I got the answer I did. That's perfectly acceptable. That's perfectly understandable. It's because names are just, again, name tags for actual things. So over here, we have x is equal to 6, y is equal to 8, z is equal to 4. We have this function over here which does stuff, but like I mentioned, until we actually call it, I'm not actually going to care what's going on. So I've got x is equal to 6, y is equal to 8, z is equal to 4, but I have z, x, y over here. That's fine. I'm going to go ahead and, so z is 4, x is 6, and y is 8. So I pass in 4, 6, and 8. Now, the first place to mess up is thinking I've got zxy over here, but I've got yxz over here. So the names need to line up with each other. No, it's all positional, right? They're all name tags. When inside this function, the name y, x, and z matters. Okay. So what we've got here is we've got, so I'm going to go ahead. So we had 4, 6, 8, 4, 6, 8. Its values, the value for 4, so y is 4, x is 6, and z is 8. So first thing we're going to do over here is x is equal to x plus 1. That increments this value from 6 to 7. Then we do y is equal to y, 4 minus 7 plus 8, which is just a long-winded way of saying 4 plus 1, right? So 4 becomes 5. So we have 5, 7, 8. And then we print out ZYX. So we print out 8, X is 7, and Y is 5. So again, these were intentionally made to be confusing and obtuse. Again, don't do anything like this when you actually code. These are great pedagogically, and I think they're great for basically stress testing your brain on your understanding of this stuff. Not so great for actual applicability, but they work with logic and they enforce the idea. Arguments are positional, the names are made up, the points don't matter. Okay. Similar for this one, ZYX. Okay, we've got 17. So over here, we've got, at least here, I'm at least passing them in order, which is that I've got X is 17, Y is 8, Z is 2. So, okay. Oh yes, I love this one. So I do a bunch of, so here's the kicker. I do all these complicated operations. They don't matter. 17. The answer is 17, 8, and 2. So here's the other thing to remember about programming languages. They are pass by copy. All right, if you could just tone it down for a second. Okay. Programming languages operate when they pass in parameters, they are pass by copy. There were a couple different ways that when the languages began to be implemented that things could be done, which is that you could have, when we passed in an argument, we could have passed in like an exact clone of it. We could have passed in something, we could have passed in the memory location to it. So that's kind of where we kind of did. They are passed by copy. So for instance, for numbers, we just copied them over into here. These are copies of those numbers that got passed in. Now, that said, when we're dealing with lists and we're dealing with strings and we're dealing with turtles, you're like, but we don't make copies of those. If I pass a list into a function, I can change the list. If I pass a turtle into a function, I can make him draw. I don't suddenly get a second turtle. That's a clone. So for objects, which are those complicated things that are more complicated than numbers, that copy is a memory location where you can find that thing. You don't actually copy because those things like strings can be big. They can be giant, Russian length novels. And you don't want to copy those willy-nilly, otherwise you're going to eat up all your memory, or you would in old systems, So similarly with a list, which could be huge amounts of numbers, huge rows and columns, if you're passing that into function, you don't want to copy the entire thing. That could be gigabytes of data. You don't want to copy that. So you send in a memory location. That is why. That is, and that is the way it works in C. That is the way it works. Sorry, that's the way it works in Java. That is the way it works in pretty much every modern programming language. So the way it works in C too, C just doesn't do things automatically for you. C is very explicit about how it also doesn't have objects, but you define whether you're going to be copying the thing or whether you're copying the value or you're copying the memory location where the value is stored. C is annoying because you have to do that all manually. So here, again, if you don't believe me, copy this code, run it. I don't typically do trick questions like that, but again, practice exams are fair game for tricks and things like that, because it's a great learning opportunity to get. Yes. Yes, that's a great question. The question was, if the print was inside the function, would we actually have to care? And the answer is yes, because we'd be doing those operations on those copies, and then we print out the values for those copies. All right, write a new function called print3's limit, which prints all the positive numbers less than limit that are divisible by 3. If limit is less than or equal to 0, then we just don't do anything. Okay, so let's go ahead and comment all this out over here and get to doing a print def print 3's given a limit. Okay. When it comes to writing a code, to writing some code, expect one question like either the print and reverse question or this question, where you're given, where you're given code and you need to do some kind of for loop. This one's a bit more advanced because it requires, well, it doesn't require an if statement actually if you structure your for loop properly. But what we're going to do is we're going to say for a num in range, and then we're going to go, so it says if if limit is less than or equal to 0, print nothing. So I can just simply say 1 to our 1, and then let's see, did I specify all positive integers less than limit? So I can say go up to but not include it. And now if we get a limit that's less than this, it's just not going to run, right? So an if statement isn't necessary, although it would be more clear, which is its own. I'll be posting the answer key of the as well as recording. I'm going to double check. I think I have an answer key for this. Okay, so print 3's in, so for num in range 1 to limit. So what we need to do, so this part does require an if statement, because prints all the positive integers that are less than limit that are divisible by 3. Well, technically, we can still do this without an if statement by saying, hey, start at 0 instead, and start at 3 and go up by 3's, right? And then print out every number, right? So careful construction of a range statement can do a lot of work for us and not have to make us use an if statement. So this question is basically agnostic to whether or not you care about if statements. And on the actual exam, I don't care about if statements. I'm not testing if statements on the first exam. I care about loops and turtles primarily. So this is the one way to do that one. If you wanted to use an if statement, then this is where we would have to use modular arithmetic. So we would basically say either start at 1 or whatever. And we'd say if num mod 3, if the number divided by 3 equals to 0. So if that number is cleanly divisible by 3, then that means it's a multiple of 3. So print that number. So like I said, I like questions that can be answered in multiple ways. Okay. So there's other questions here. So this is a question I really like, which takes in an integer and returns how many digits you have. It has. This can be done because, again, this is one of those questions that has multiple ways to solve it, right? is actually one that I used to ask, that I do sometimes ask on some exam, that I have asked on exams in the past, which is num digits. Take in a num, tell me how many digits it has, right? The usual mistake that I get is that people will basically do this. Print, they'll think they can do it in one line like this. Num length of number, sorry, print the length of the number, which is intuitively, logically correct, correct way of thinking it. So if that was your first instinct, it's not a terrible instinct, but you'll get an error if you actually run it. So it's num digits in 4, 5, 6, right? Which would give us, that's 3 digits. We'd want to get 3 out there. Num digits. Okay, now I'll get a different error where it says, hey, you gave me an integer and I'm doing this operation over here on line 7, where I do the print length of a number, but the object of type ints don't have a length, right? Ints are just numbers. It's not a function that's applicable right here. Numbers don't really have functions. So you can't do it in one line, unless of course you turn that into something that does have a length, which is the second instinct that students typically have if they realize that the first attempt is wrong. Which is totally not what I intended for students to do the first time I asked this problem, because I intended it to be a mathematical operation. To do it with a mathematical operation, this one requires a while loop to solve, right? To solve it with a while loop, which is just simply an if statement that you keep repeating, you do it like this. And this involves no conversion whatsoever. While the number is greater than 0, greater than 0, first I'll do a one number, so let's see, digits is equal to 0, and we do an accumulator. So one number is greater than 0, what I'm going to do is I'm going to increment the number of digits by 1. And then I'm going to toss out a digit. And that sounds weird, but what I'm going to do is I'm going to say digits. So I'm going to say num is equal to num divide 10. And what that does is that tosses out the ones place. Right? So I would go from 4, 5, 6 to 45. Because I'd be dividing by 10, right? With integer division. It's a very useful strategy there. So I just simply do that and print digits. So that's another way to solve that. On the exam, though, again, I don't care how you solve things unless I specifically tell you I care how you solve it. Right? It's not one of those things you have to worry about too much, though. Again, I do like, it's perfectly fine. So what can you use? Again, I think, now what did I say the note policy was for the exam? Refresh my memory. Did I say 1 sheet front and back? Yep, 1 sheet front and back. That's what I thought I said. So 1 sheet front and back. But in general, if it exists in Python, if it exists in the programming language, you can use it. It's fair game. Okay. So if you know, so if you're not, in other words, if you see a question on the exam that you're like, oh, this is a perfect application for dictionaries, which is a thing that's built into Python that we'll learn about. And I don't think we have anything in the exam that's a perfect application of dictionaries, because those are typically questions that are specifically set for dictionaries. But if you found one and you didn't know how to use, and I didn't teach it yet, you're more than welcome to use it. You're more than welcome to use lists. You're more than welcome to use if statements. You're more than welcome to use lambda expression, anonymous functions in this exam. Yeah. You're allowed to use list comprehensions if you know what those are. Mhm. So, but let's see, how many questions are on the exam? Not too many. I was gonna send off my exam to the printers today, but I had forgot to upload my exam to my private GitHub. So I left it, so I'll have to send it out tonight. But no more than 10, I would think. So no more than 10, if you consider if you consider then no more than these things to be in, but I count like doing 5 of these as one question. Yes. I can't hear. So yes. So again, it's a 2-part exam. The first part, you're doing it by yourself. The second part, you're retaking the exam, but as a group. So that way means that basically if you get questions wrong, you'll get the chance to immediately correct them. Because in general, those groups. So yeah, if you can just stay for one moment so I can explain how this is going to work, okay, on Thursday. Okay, the way the group exam will work is that these groups are self-forming. In other words, when you're done with the exam, I say it's time for the group exam. Find a group of 3 or 4 people, including yourself, then come and get an exam from me or a TA. That's the way it works. Okay. So no more than 4 people in a group, no less than 3. Unless, of course, there's a remainder. You know, in which case, we'll figure that out. Yes. Here, we're taking the exam right here. The exam is so the first part of the exam is 50 minutes. 50 minutes so that we can have about 25 minutes for the group exam, because assume it takes about 5 minutes to collect all the exams / repass them out. The actual exam itself is 50 minutes. So this class is an hour 20. So give 50 minutes for the solo portion, 5 minutes for changeover, 25 minutes for the group exam. Now, and again, you're retaking it, so it's not going to take nearly as long. Yes. We're going to aim for 3 plus the final. So one when we come closer to the, one will come right before we start doing our group project, and one will come in kind of the area where we do our group projects. And that will cover anything like the last remaining things, like Monte Carlo approximations. Okay. All right. If that is all, class is dismissed.
So I'll try to. I'm not sure if I should or should not get a DRS room, or because it's 50. It's not if I can. This is not the ideal example. I'll try to book it, and if
yeah, what I would do. So here's what I suggest: book a room. Okay. Although it might be a bit late for that. So what you should do in the future is book a room. Okay. And if you just need the time, okay, like if you find that the time is more valuable than doing the group portion, you can book it so that you can take the 50-minute exam with the required amount of time if you can't get a time for Thursday. Right?
I'm more concerned about the ergonomics paper.
Yes. That's what I'm talking about. So if you're more concerned about that and you want to take that exam like next week as a result, but miss out on the group portion, you can do that. If you think you can schedule a room for
maybe 1 hour before classes.
Yeah, but again, it's probably talked about this a bit beforehand. So
yeah, I realized that.
So the in the future, what you want to do is schedule your exam so that you have like enough time to get so that your timing at the sentence where at your reservation ends, and then you have enough time to walk over before the group part begins. Right. Make sense? Okay. So for this time, like again, if you're more concerned about the ergonomics, we can you can set up the DRS for whenever, and then we can either handle the we can either handle the group exam some other way, okay, depending on when that is. Or we can just simply just have it all be like a standard exam.
Yes, now the next question is. Do the AWS educate?
Nope, they just had comfy shirts.
Okay.
They were handing them out and I had a comfy shirt. Yes. Let me try to answer these questions first, if you don't mind, before I do demos. Yes.
When I. well, all of my organizations are and I just have like. Base doesn't have internet access, that is a non-security, but I was able to do everything that I should have done. However,
Mhm.
when they changed the DRS system to a new one this year, different from the old one, which